Hey, what's going on, guys? Let's do this problem right here. Here this question is asking a force of 10 pounds is required to hold a spring stretched 4 inches beyond its natural length. How much work is done in stretching it from its natural length 6 inches beyond its natural length? Now let's see how we can find it. First of all, in order to do this question, we have to know the generic equation to find out work. To find out work done by a spring system, we use this equation. W is equal to integration a to b f of x dx, but for a spring system we use Hooke's law. Hooke's law is kx dx, right? So here f of x is equal to dx. Not dx, kx. F of x is kx for a spring system. So this is what we are going to use to find out the work. Now, in order to do this problem, we have to know limits of integration and k, that is spring constant, and x value, right? Now let's see whether we have all the information available. First, we have to know the limits of integration. Limits of integration, we use the length, the stretched length. So natural length, we always take that one as 0, and stretched part is this one, 6 inch. So we have these two information. Because natural length 0, this is stretched part, so we have these two. Spring constant, they haven't given in the question, so we have to find that one out. And x is going to be, we are going to apply this limits of integration after we integrate this one, right? Now we have to find spring constant in order to solve this problem. To find the spring constant, we have to use the first information that's provided. They have said that a force of 10 pounds is required to hold a spring stretched 4 inches beyond its natural length, right? So we can use this information to find out the spring constant. Now, since they have given the force, we know that in spring system, to find out the force, we use this equation. F is equal to kx. K is what we are trying to find. F is provided, that is 10 pounds. 10 pounds is equal to k, and x is stretched distance. This is 4 inch, but in foot pounds system we have to use foot instead of inch. And to convert inch into foot, what we have to do is we have to divide this one by 12, and that's going to give us a foot. Now if you rearrange this one, k is equal to 12 times 10 divided by 4. This is going to give us 30. So 30, this is going to be 30 pounds per foot. So that's going to be the spring constant. Now we can apply this one into this equation to find out the work. Now let's go ahead and plug all the values. Work is equal to integration. So they have mentioned that is stretched 6 inch from the natural length. Natural length is 0. 6 inch mean if I want to convert this one into foot, I have to again divide this one by 12. So if you divide 6 by 12, that's going to give you half, right? So this is going to be half, and here we are going to put 30 instead of spring constant. So this is going to be 30x dx, and this is an easy integration. If you integrate this one, this is going to be 30x squared divided by 2, and that's going from 0 to half. And if we can simplify this one more time, that's going to give us 15x squared going from 0 to half. Now let's plug this one. Here we are going to have 15 times half square minus, and if you plug 0, everything is going to be 0. So we can just put 0 right here. And if you calculate this one, that's going to be 15 divided by 4, and that's going to be the final answer. 15 over 4, and units of work is going to be foot pounds. And that's how we do this kind of problems. I hope this helps. Thanks for watching.